So let's begin day two's content with inequalities. An inequality is a set of numbers, whether on a number line or coordinate plane, and you will show your solution set for a set of inequalities through shading. For example, let's say you have x is greater than -2. On a number line, this means, let's see, centered at 0, beep, 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 bing, 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 bing. You'll put an open circle where x equals -2, shade everything above that. On a coordinate plane, you would go to where x is -2, and shade everything to the right of it. You always highlight where's the x value, and then shade right or left as needed for an inequality. On a graph, you'll use an open or closed circle. Use an open if you have x is greater than or less than some number. You'll use a closed circle if x is greater than or equal to, or less than or equal to that number. An open circle will look like this. A closed circle will look like this. And if you're doing this on a two-dimensional graph, meaning that if you're doing it on the coordinate plane, for x is less than or x is greater than, you'll use dashed lines. For a closed circle, you'll use a solid line. And in the event that you're looking at a problem that has multiple inequalities, the best way to do this is just graph on Desmos and look for overlap. Graph and look for overlap. Where both graphs shade in, which for example you have a red line and you have a blue line, where the two areas shade purple, that's what you want. So let's look at some release SML questions and how you would apply this. Number 1, what is the simplified inequality? 6 minus 11 minus 13x less than 7 minus 5x. There are two ways to do this. Number 1, you treat this like an equal sign and you solve it algebraically. Combine your like terms. -7x minus 11 is less than 7 minus 5x. Add your smaller x to both sides. Remember, -7 is less than -5. -11 is less than 7 plus 2x. Subtract your number from both sides. -18 is less than 2x. Divide both sides by 2. X is greater than -9. This is how you would solve the problem algebraically. Alternatively, plug this into Desmos, look at the graph, and look where your graph shading stops. As you zoom into that x coordinate, you will see that there's a line where it almost hits -9. You can take this picture and get the answer. Oh, that means my graph is x is bigger than -9. Use whichever method works best for you. Number 2, graph the solution set to this inequality. For this problem, plug it in Desmos. You don't need to do anything fancy, don't need to do anything algebraic. Just take this whole thing, put it into Desmos. Because I don't have Desmos open, I'm going to work this out by hand. La da da dee, la da da da, la da da dee, dee da. Let's see. Sorry, I forgot to distribute the negative. 6 is greater than 3x plus 6. 12 is greater than 3x. X is less than -4. Okay. And when you plug this into Desmos, you will see this. At x equals -4, you'll see a wall everywhere to the left of it. So here's how you would graph that on your number line. You'll put a hollow dot, an open circle, where x is -4, and you would graph everything to the left. Ta-da! That's it. Number 3, graph the following inequalities. Here again, it's Desmos time. Plug both of these into Desmos. Y is greater than 2 minus x, 0, 2, 2, 0. Use a dash sign. My dash is a little bit better. And the shading will be up here. For number 2, y is less than, or sorry, second part, y is less than or equal to 3x minus 2. Bing, bing, bing. This would use a solid line because it's testing y is less than or equal to 3x minus 2. This is what your graph would look like. Key features that you have to highlight are the solid line versus the dashed. As long as you have those components, the shading right, you're all set. And this is a way to lead into the next problem. Using the inequalities shown, create a system of two inequalities that can be represented by this graph. I'm going to enlarge what's down here. I need to fix that on your paper. Y blank, -1/2 x plus 2, and 2x plus 5 blank y. Your goal is to put the appropriate inequality symbols here and here. Easiest way to do this problem, guess and check. Yeah, just try okay. Let's try y greater than, y greater than. If that didn't work, let's try y less than, etc., etc., etc. Guess and check, find a match. That's how I'd recommend that you do this problem. If you want to do it systematically, the way that you would do it is, let's see, this is 2x plus 5. It's the up and down line. So let's see, 2x plus 5 y. Here this would be dashed. So this means that you will have a less than or greater than symbol. Excuse me. So this means 2x plus 5 is 0, y is 10, false. I think that y would be less than that number. Let's check that real fast. 0, 3. Yes. The vertical going line, the dashed line, is 2x plus 5 is greater than y. Let me erase the line underneath so as not to cause confusion. And in the second problem, it says that y is greater than or equal to, because it has a solid line, -1/2 x plus 2. So you would fill in your inequalities, and that would be the solution. Continuing to the next slide. Number 5. Zach began graphing the system of inequalities below. Y is greater than or equal to 2x plus 1. 5x plus 6y is less than or equal to -30. To complete the graph, Zach must shade the region which represents the solution set to the system of inequalities. What region of the graph needs to be shaded? So for this problem, throw it in Desmos. Just throw it in Desmos, be done with it. When you throw this in Desmos, for y is greater than or equal to 2x, 2/3 x plus 1. Graph everything above. And then for 5x plus 6y is less than or equal to negative 30. Let's see, this means that y is less than or equal to negative 5 over 6x minus 5. Sorry, this is my mental note for trying to do this by hand. It looked like this, and so that would be this half right here when shaded. So your target area would be right where they overlap, which would be in section 2. Finally, Frank works at a convenience store. He earns $7.50 per hour when he works during the day. He earns $12.50 per hour when he works at night. He wants to earn at least $300 per week. Which graph best represents this situation? So take a moment to look at the various graphs here. Number of hours worked at night, hours worked during the day, Frank's weekly earnings. So this is a problem where you're going to have to think through it a little bit. And this will be a high difficulty problem. Here's what we can see first of all. Frank can work at the convenience store presumably as many hours as he wants. And so the first two graphs A and B would not work because they both have shading stopping when he hits a certain number of hours. Let's cross those out. For this problem, I'm going to show you how to do it by elimination. Now it's time for C and D. Frank wants at least $300 per week. So let's take option D, just because I'm looking at it right now. The number of hours worked at night. If Frank were to work 40 hours at night, 40 times 12.5, $12.50, would give him $500. That's higher than the target amount that we want. By comparison, for C, the number of hours worked during the day at 40 times 7.50 would be 300. That makes sense. The number of hours worked at night here is kind of hard to estimate it. We can put in a rough estimate of maybe that's 24, 25. I'll say 25. 25 times 12.5, or $12.50, would give him $312.50. Which, okay, it was probably 24 for the target of $300. Therefore, the graph you want would be C, because it has the correct shading. And everywhere that's shaded, that means he makes at least $300 per week. The x-intercept is correct. Number of days, it's 40, 0. The y-intercept is correct. Meaning that night, 12.5 times, I think that's supposed to be 24, would give you 300. The correct answer would be C. This is one where, here again, if we have more time to look at word problems, wonderful stuff. Let's actually apply this. And hey, this type of graphing is what I use when considering, okay, how many hours do I have to work at school, or do I have to work a side gig in order to make a certain amount of money, such as to pay for my car, my lawnmower, my kids, everything's. So this is good stuff. This is stuff that if we were not reviewing for the SOL, I would love to talk more about. But we are preparing for the SOL. And so that means we have to go ahead to part 4.